I'm Mike, and I'll be guiding you through this training. These next 2 slides show the objectives. Recall, ions are electrically charged particles. Substances that form ions when they are dissolved in water are called electrolytes. There are 3 types of electrolytes. They are called acids, bases and salts. When water separates, it breaks apart into an equal number of hydrogen ions and hydroxide ions. In contrast, when other substances dissociate, they may release more hydrogen ions or more hydroxide ions. For example, hydrochloric acid, HCl, releases more hydrogen ions as it dissociates. Sodium hydroxide, on the other hand, releases more hydroxide ions. Depending on its concentration of hydrogen ions versus hydroxide ions, a substance can be classified as either an acid or a base. The pH scale measures how acidic, or how basic a substance is. The scale ranges from 0 to 14, with 7 being neutral. When a substance has a pH of 7, like water, it releases an equal concentration of hydrogen and hydroxide ions. When a substance has a pH greater than 7, it's classified as a base and releases a greater concentration of hydroxide ions. The more hydroxide ions that are released, the more basic the substance. Bases tend to feel slippery and are often used as household cleaners. Milk of magnesia and ammonia are both common bases. When a substance has a pH of less than 7, it's classified as an acid, and it releases a greater concentration of hydrogen ions. The more hydrogen ions that are released, the more acidic the substance. Acids tend to taste sour. Lemon juice, stomach acid, and coffee are all examples of acids. Litmus paper is used to estimate the pH of a substance. You dip the tip of the strip of paper into a container of a small sample of the substance, and match the color, on a color-coded chart, to estimate the pH. Salts are defined as ionic compounds that ionize, or dissociate in water, but do not produce either hydrogen or hydroxide ions. When acids and bases are mixed in solution, they neutralize each other, and produce salt, and water. For example, hydrochloric acid reacts with sodium hydroxide, a base, to produce sodium chloride, table salt, and water. Also, nitric acid reacts with sodium hydroxide, a base, to produce sodium nitrate, and water. Now back to pH. To understand pH, you must understand logarithms. Consider the number 64. 64 can be expressed exponentially several ways. The number 64 can also be expressed logarithmically. For example, if we start with one of the exponential forms, 4 to the third power equals 64. We can express that logarithmically using this expression. Always remember, when doing this problems, the logarithm, what goes after the equal sign is always the exponent. In this case, 3. This is read, the logarithm or log of 64, to the base of 4, is 3. The base, in this case, is the number 4. Notice that in the logarithmic expression, the base goes at the bottom, just like the base of a mountain. Therefore, we can state that the logarithm, y, of a number, x, to a base, b, is the power to which the base, b, must be raised to yield the number. While the base can be any number, we'll be using base 10 for most calculations. These are sometimes called common logs. It's the same concept as before. If log 1 equals 0, then for numbers less than 1, the log will be negative. When dealing with common logs, it is common to leave off the 10. If there is no number where the base value should be, it is understood to be base 10, or a common log. Recall the pH scale we discussed earlier. We'll now discuss where those numbers come from. The letters P and H stand for the power of hydrogen. However, that's not important. What is important is that pH is the measure of the hydrogen ion concentration in a solution. Note the brackets around the H+ refers to the hydrogen ion concentration in moles per liter. Recall that this is also called the molarity, denoted by a capital M. pH is defined mathematically as the negative log of the hydrogen ion concentration. For water, the hydrogen ion concentration has a value of 1 × 10⁻⁷ power molar. Therefore, the pH is the negative log of this value, which is 7, which indicates a neutral solution, which we should expect from pure water. You may also interconvert pH and hydrogen ion concentration as shown. Here's another example. 0.1 molar hydrochloric acid. The pH is 1. Since 1 is less than 7, this is an acid. Actually, in this case, the name, hydrochloric acid, probably gave it away. Note that a substance with a pH of 1 is 1 million times more acidic than a substance with a pH of 7.